All right, this is the Algebra 2 Unit 3 review video where I'm going to go over the study guide that I sent out to you for Unit 3. I'm going to go over the questions that have solutions. Make sure that you're paying attention to the vocabulary on the study guide as well. I'm not going to go over that during the review. That's just something you need to take responsibility for. So make sure you look at the vocabulary, and that's my disclaimer for that. So let's jump in. I'm going to close my video and switch to tablet mode here. So looking at the first section, this is all about adding, subtracting, and multiplying matrices. This is stuff that we covered early on in the unit, but just as a reminder, remember to add or subtract matrices. You add or subtract things that are in the same position. So when you're done, you'll have a matrix that is the same size as your original one. And so, for instance, if this was my problem, I would do 4 and 1. I would add together, and those would make 5. That would be the first term. 8 and 0 would be added together to make 8. 3 and 5 would be added together to make 8. And 7 and 2 would add together to make 9. And that would be the answer matrix. Subtraction, similar idea. So when I add the numbers or subtract the numbers, 2 minus 5 is negative 3. 8 minus 6 is 2. 0 minus 11 is negative 11. And 9 minus 3 is 6. So again, I'm just adding or subtracting, depending on what it is, each number with the number that is in the same position. Then we have this question about scalar multiplication. So scalar multiplication is when we multiply matrices by a single number. And all that happens is that that number gets basically distributed throughout the matrix. So 2 is going to be multiplied by all 4 of those numbers. So it's pretty straightforward. 2 times 10 is 20. 2 times 6 is 12. 2 times 4 is 8. 2 times 3 is 6. And that is it for scalar multiplication. So those are probably the easiest ones that we worked with. But when I multiply 2 matrices by each other, it plays out a little bit differently. So I'm going to write some notation here, just kind of help us along. Remember that each spot tells us to multiply by a row and column pair. So I'm getting this information just from the location in the answer matrix. So for instance, if I'm looking at this term, it's going to be the multiplication of row 1 with column 2. So when I go over here, I'm going to look at, I'm going to go ahead and put equals and write our final answer matrix. We're going to multiply row 1 times column 1. So when I say that, I'm going to multiply 0 times 2. I'm going to go ahead and show you what I'm doing here. I'm going to multiply 0 times 2. And then I'm going to multiply 4 times 3, and I'm going to add the answers. 0 times 2 is 0. 4 times 3 is 12, so I add those up and I get 12. Now on the next one, I'm going to do 0 times 5, and I'm going to do 4 times 0. Again, I'm doing row 1 here, row 1, column 2. And that's going to go here. So 0 times 5 is 0. 4 times 0 is also 0. So when I add those together, I remain 0. All right, so let's go back here. Let's look at our other row. Row 2, column 1. That's going to be row 2, column 1. That's those pairs of numbers. So then I'm going to do 5 times 2 is 10. 2 times 3 is 6. Together they make 16. I'm going to go and move my second one here and move it over so that it becomes the second column. And we'll do row 2 times column 2. 5 times 5 is 25. 2 times 0 is 0. So we get 25. And that would be the final result of that multiplication. recommend going back and watching the video over that if you still don't really know what's going on. But basically, you're doing the information that I just showed you. So go ahead and go check that video out if you need more of that. You can always just Google multiplying matrices for more examples of that as well. All right. Next is going to be calculating the determinant of matrices. So calculating determinants, you need to be able to do it with a 2 by 2 and a 3 by 3. 2 by 2s are really easy. You multiply the downward two numbers together, what we call the downward diagonal, and you multiply the upward diagonal. Upward diagonal, and we do the downward minus the upward. So we're going to do 5 times 2 is 10, minus 8 times 4 is 32. 10 minus 32 is negative 22, and that's it for the determinant of that matrix. Now, in the next one, it's a little bit different. If you remember, I need to extend my matrix by adding column 1 and column 2 again, so that when I make my diagonals, I can sort of circle back on the matrix. So again, I'm taking column 1 and column 2, and I'm writing them again, because we're going to do quite a few different operations here. We're going to do the upward diagonals, the downward diagonals. And we're going to subtract the upward diagonals. Now, let's go ahead and work this out in one long thing. So again, downward diagonals are going to go first. It's going to be 2 times 7 times 1 plus, you could put those in parentheses if you wanted to, plus negative 5 times negative 2 times negative 1 plus 3 times 0 times 4 minus negative 1 times 7 times 3 minus 4 times negative 2 times 2 minus 1 times 0 times negative 5. So again, I'm going to work each one of these little things out and get an answer. 2 times 7 times 1 is 14, plus negative 5 times negative 2 times negative 1 is negative 10, plus 3 times 0 times 4 is 0, minus negative 1 times 7 times 3 is negative 21. 4 times negative 2 times negative 2 is minus negative 16. And then minus 0 again, because that makes a 0. So those are just going to go away. And then we need to work all this out and add it up to one final number. Let's see what we get. 14 plus negative 10, that's going to be 4 minus negative 21. So that's actually going to be plus 21. That's 25. And then again, plus 16 is 40. Oops, sorry about that. Is 41. Feel free to use the calculator as much as you need to in that problem. And again, watch the video for more examples. If you're not sure, you remember how to do determinants. All right. Next one is actually right here, row operations. 3 types of row operations. You need to be able to identify them and perform them. So it won't take too long here because they're pretty straightforward. But first of all, row switching is just literally you switch the rows that they tell you to switch. So we are going to switch row 1 and row 2, and then the final answer matrix will be as follows: 2, 4, 5, 4, 8, 3, 7, 1, and 2. Notice all that happened is that the first 2 rows switched, and that's it for that one. I guess I should write it with the correct notation. So here it says to do row 1 plus row 2 and to put the answer in row 2. Well, so we're going to add the 2 matrices together and we're going to write the answer in row 2. So 2, again, I'll do each, I could almost add it down. 2 plus 0 is 2. 3 plus 8 is 11. 4 plus 1 is 5. That is going to go in row 2. 2, 11, 5. And then 2, 3, 4 remains in row 1. That is row addition. So that's it there. And then lastly, row multiplication. They're telling us to take row 2, multiply it times 3, and write it in row 2. So row 1, row 3 are going to remain unchanged. So I'll go ahead and write those down. 6, 6, 1, 4, 5, 9. And then I just need to multiply row 2 by 3. So 3 times 2 is 6. 3 times 3 is 9. 3 times 0 is 0. And that would be the end of that one. All right. That's row operations. Last two are pretty quick. Test if the matrices are inverses. To test matrices are inverses, you need to multiply, and then you need to find out if it ends up being this. If it does, the answer is yes. So here we go. Let's multiply these two matrices together. Row 1, column 1. 3 times -1 is -3. -1 times -4 is 4. Add those together, that is 1. I can go, and I just realized I made a mistake there. I should have done row 1, column 1. 3 times -1 is -3. 4 times 1 is 1. That works. We can grab this and say we're going to now do row 2. 3 times -4 is -12. 4 times 3 is 12. Add them together, they make 0. I'm going to move this guy down. Move this guy across again. -1 times -1 is 1. -1 times 1 is -1, so they add to make 0. You can probably see where this is going. So I'm going to move this guy over. -1 times -4 is 4. -1 times 3 is -3. That makes 1. And so we say, yes, they are inverses because we got the answer we were looking for, which is what we call the identity matrix. Lastly, I'm going to go ahead and open the graphing calculator. Solve systems of linear equations. You do not have to use the method they say. You simply need to graph these two equations here. So we're going to jump over 2x minus 3y equals 0. And then the second one is -4x plus 2y equals 8, -8. And we look for where they intersect. These intersect at the point 3, 2. And so that would be the answer that we're looking for, 3, 2. And that is it for that one. All right, so that's pretty much it. And I've given you examples of everything here. So you should be good to go for your study guide answers there. Please reach out to me if you have more questions or you want more sample problems. I'm happy to give them. And then I'd like everybody to be tested by the end of the week.